Hello everyone, welcome to Mojo for Industry Presents Digital Dialogue on laser cutting in smart manufacturing, sponsored by Maser Cutting Systems India. My name is Subjit Roy and I will be your host for this insightful session. Thank you for joining us today as we dive into the cutting edge technology that is reshaping manufacturing industries worldwide. Laser cutting, powered by smart manufacturing techniques. We will cover how laser cutting integrates with smart technologies to increase efficiency, precision, and of course, flexibility. Highly skilled experts from Mesa Cutting Systems India, Mr. Duraiswamy Ravichandran, DGM Product Management, and Mr. Karthik M, Manager Product Management, will share their insights into how integrating laser cutting with smart manufacturing techniques enhances precision, boosts productivity, and ensures high quality outputs. Viewers, after the individual presentations, we will open the floor to your questions and observations in our interactive Q&A session. So please share your thoughts in the Q&A box in your Zoom control panel. We will address them at the end of the session. So our first speaker is Mr. Karthik M. We are excited to hear from him on the advantages of laser cutting systems in manufacturing and integration of laser cutting with smart manufacturing. Over to Mr. Karthik.
Thanks for time, Mr. Subjit, and good afternoon, everyone present. This gives an immense opportunity, to connecting with all the customers through online. And thanks for keeping us joining and keeping us integrated within customers. So let me share my screen, and sorry for a couple of minutes delay because of the technical glitches what we faced.
Is your screen is visible?
Karthik? Yeah. Okay. So as Mr. Subji said, we're from Messer. It's like 125 years old company, and we have 5 global locations, and the parent is of course from Germany. And on the right side, you see our current operating CEOs with the 4th generation leadership. So we are originally into many business, like from gases to medical equipments to primarily onto the serving various industries with different set of gases. So that is our major business, and we also the one of pioneer persons who are in the cutting business. So we have a global presence in various countries for gases, and of course 5 global locations for the cutting division. We're a global player in every particular cutting industry. So these are global spread, whereas we have a plant, as I said, in North America, that is in Wisconsin. The second is in Brazil, the Europe, that is from Germany, and India, and the territories of India, with including parts of Middle East that is taken care by Indian territory, and another location from China. And for all the China, the eastern parts of the globe is taken care from China. So those are global presence. Here's from India. So these are like the 5 companies, and the bottommost is our plant that is in Coimbatore. So these are widespread sales and service network. Many people would have known Messer in different parts of the country with the name of gases, but yes, we are also into the major players of cutting division. And here is our exclusive laser, plasma, and oxy-fuel manufacturing plant. These are headquarters in India, which is present in Coimbatore, Tamil Nadu. And these are full-fledged extreme team, which are spread across India to the territories of India, like Middle East, southern parts of Africa, to Bangladesh and Sri Lanka as well. So these are widespreading hands who help us to meet customers, engage with them, provide solutions and everything. So to start with, everybody knows that we are into thermal cutting equipments, and basically the thermal cutting process is split into 3 segments, that is oxy-fuel, plasma, and laser. And as I said, the oxy-fuel is the very old and the traditional method of cutting, where the thickness or the capacity of cutting is much higher when you compare with plasma and laser. It goes up to 300 mm. So it's a very basic process that you heat the metal, blow the metal, and then it starts melting away. So that's a very traditional type of cutting that is called the gas cutting or the oxy-fuel cutting, that is taken with LPG or acetylene as the fuel gas with oxygen. So that is one kind of the plasma where you go for creating an electric pressure between two different potential air gaps. So there you produce a arc, and again this arc is being shielded with the shielded gas, and the process is flown, so the metal melts and then it is carried away. So that way you achieve the plasma, and plasma is also called as the fourth state of matter, where you cut through an electric arc. So the potential gap is obviously maintained, and then you go for cutting, that is with the plasma. So these two traditional, or I would say the conventional type of cutting, is replaced nowadays with the laser. So that's the reason that we are having this session. Why laser? Why we need to go for laser? Or what are the advantages, or what are the specific things that laser gives more than oxy-fuel or more than plasma? Though there are certain advantages over oxy-fuel and plasma, we have a specific, or I would say an exclusive benefits that we achieve from laser. And that is why in recent days, this particular laser segment is like booming over the plasma segment. Of course, it takes, I think, little time to capture the oxy-fuel segment as well. But I foresee that the way that the laser business or the laser products that are getting expanded in the market, they're so fast in catching up both the segments of oxy-fuel and plasma. And laser is again a typical process, a similar process, I would say, compared with oxy-fuel, where the fuel gas there in oxy-fuel process is the fuel gas itself, whereas here the fuel is sourced from a light. So when we focus a beam or a ray of light towards a particular point, or it is focused at an intensity of a very fine spot, say 0.125 mm or 0.15 mm, then the melting starts. So once the melting starts, again, it is a fusion process where the oxygen is blown or the nitrogen is blown to carry away the molten metal. So that is how this process is basically explained. And here is the capacity that you can compare of why oxy-fuel, when to choose oxy-fuel, when to choose plasma, and when to choose laser. So when you have a higher capacity, go for oxy-fuel, and you have a medium capacity, go for plasma. And then with the laser, at least now we have limited to certain thickness, that is 30 to 40, because of the product which are widely found in laser is up to 20 kilowatt, at least until now. But of course, there are much higher powers which are available in market. Since we are, speaking about a very prominently available or very stabilized product that is available in market as of date is 20 kilowatt up to. So that is why we have mentioned thickness of 30 and 40 mm. But when you see the capacity, the oxy-fuel, where when you want to go for intricate cuts, it is the whole ratio, that the thickness to the whole ratio, that is 1:2, whereas in case of plasma, it is 1:1. So that's a maximum possible thing that you can achieve in plasma. When you come for laser, it is much lesser. So that is one of the very intricate thing that you find in laser. You can go for intricate cutting, you can go for accuracy. So when you want to combine the accuracy with a clean cut, or I would say with a nice finish, then obviously I would say it is a two different techniques of plasma and oxy-fuel combined to one. So two different advantages combined to single, that is this laser. So going on, this was the original, I would say it is a map that we have prepared to plot when do you choose what process. So again, it is like thickness to precision. That is what it means on this chart. The x-axis is precision and the y-axis is thickness. So this was our chart traditionally, but due to the increase in the laser market or the laser products globally, the developments what we are seeing in laser is so rapid and so fast that the capacity is being eaten away. There is a portion of segment that is eaten away from plasma. So we see there is a rapid change or the rapid growth that is happening from plasma to laser. And these are like what I said, as advantages. That is, the first thing is precision and accuracy. So definitely onto the intricate cuts with tight tolerances, laser is going to play a major role. And whereas when you compare the material versatility, so material versatility, what I mean is while you compare the mild steel to plasma and laser, it more or less it is, I would say it is the same. But when you go for the non-ferrous metals like such as aluminum, stainless steel, or brass for that matter, plasma, the rate of material loss and the rate of the rate that you lose material, or the accuracy or the savings what you get from laser cutting versus plasma cutting, laser has much advantages over the plasma. So you can save a lot of material as well. The cut is very clean and neat. So that is one of the big advantage of laser over plasma. And of course, the surface finish, what I mentioned. The important factor that we come here is the heat affected zone. So what do we mean? The heat affected zone is the area or the path of cutting, which when done by plasma versus laser, the heat affected zone is much less than when you compare plasma and laser. Laser is much lesser. So that is again one of the reason why when you want to do a post processing on a cut hole or a cut slot, laser gives you much more easier process than a plasma, because the heat affected zone is much higher in plasma. And when you can, check the speed and efficiency, obviously, plasma definitely takes a higher position when you go for higher thickness, whereas in the lower thickness, laser is unmatchable. The speeds go up to 30 meter, 35 meter for a 0.5, 1 mm sheet of stainless steel or a mild steel. The speed is so higher that even the fastest process cannot match. The till date, I think the laser is the only process with which you can go for that higher speeds of 35 meter per minute or 40 meter per minute with high power laser. And obviously the running cost. The running cost plays again a major role while you want to choose the process. So with the advantage of laser, definitely the running cost is much lesser when compared to plasma. So as I said in the beginning, it is having a both advantage and the disadvantage. So we better choose the process based on our end application. So we try to find the application in a better manner, and then we suggest our customers to go for whether to opt for a plasma system or an oxyfuel system or to the laser system. So this is a sample high power capability chart, which again, as we mentioned, we quote though the thickness of 30 mm, 40 mm in the initial slides, but we have the capacity up to 80 mm depending on the power. So 30 and 40 kilowatt are just started entering into the market. Of course, we have cutting with air. So the advantage when you go for high power laser is that you can opt the air cutting process much affordable, because high power laser gives more, it leverages the air cutting efficiency, the air cutting process, which makes the running cost even more lesser than the traditional one. So going on to the products of Messer, the first is the Fiberlight. And this particular model, we have three different variants. One is the very simple table of 3015 and 4020 size. And then again, a table with the shuttle at the rear side, which has an parallel exchange mechanism. And again, the shuttle table with enclosure. So all these things are available with three different variants, 3015 size and 4020 size. And the acceleration is up to 0.8 G with a maximum positioning speed of 80 meter per minute. So this is for an entry level, I would say. And again, this is our 5th generation machine. This again is available in three different sizes of 3015, 4020, and 6020. Again, here 60 means it is 6.3 meter. That matches the maximum plate length of Indian sheets. So, and this particular product is with 1.5 G acceleration and the maximum rapid of 170 meter per minute. So this is little higher speed machine. And here is our recently launched the all new product. This is with 2G acceleration and 200 meter per minute. So the fastest cutting that you could ever achieve with the laser. So going ahead, the three machines or the three products, what you have already seen is a standard format machines, which many of you would have experienced. But this one, which you're seeing on screen, is Lemon 400. This is available for some specific and exclusive way of cutting. Like you can increase the width and length to the requirement of customer. So even if you have a length of 12 meter or 13 meter, a single plate has to be cut with a laser. Obviously, it is possible to be cut with this particular product because the length and width is not a constraint for this particular model. So we have a wide variety of available standard track gauges, which I would say the rail to rail distance and the effective cutting widths are mentioned below. This machine is with, of course, a lesser acceleration, but it has a dynamic movement with the more precision, stable cutting performance. The maximum positioning speed is up to 50, and sometimes the optional variants are available up to 100 meter per minute as well. But the acceleration is again, as I mentioned, is 0.404 G to 0.2 G. It can be again varied. All these variants and options are given for the customer's end application. So this particular again product can be coupled with a bevel system. So here you see a bevel unit which is attached to the system, and this is a vertical system. So that is why two pictures are given for more clarity. And this particular product, you can go up to the maximum power of 15 kilowatt. The length can be adjusted up to 32 meters depending on the customer need. Here you see an exclusive component, or I would say the basic details about the bevel system. So the bevel systems are basically used for preparing the edges, or I would say the weld quality or the weld preparation. So any welding needs a weld preparation method. So many do by manual, many have an angled cutting, a handheld portable system for beveling solutions. So with laser, why bevel is, first thing is you reduce much of your setup time. The first hit, or I would say the point that I would break it over here is you save much time in weld preparation. That is the initial setup time, because without a bevel process, we cannot go for welding. So if we have to do a beveling process, the first thing is cut for a straight and then take it to another machine or a manual cutting area where you prepare the edges and then you move it to the welding station. So one complete process of the actual cutting is eliminated, and two set of the setup time that is eliminated. So you could imagine the kind of time that you save when you have a bevel system is attached with the machine. And the bevel angle can be varied up to from 2 degrees to 50 degrees. So 15, 30, 45, 30 degree, 32 degree, 48 degree. So up to 50 degree, any kind of angles can be set over here. And this particular station is enabled with the latest Precitech ProCutter 2.0 version. And this is also can be integrated with the zoom head. The zoom is a system which has the auto magnification facility in that. So these are the exclusive bevel points which you can really look up to when you want to go for the weld preparation jobs. So these are the few samples that we have listed here to show the capability of the bevel system. And we have few testimonials of customers which we have our machines running successfully. This is our first machine that was given in Faridabad to a customer, Case Easy. And here's a happy customer face. Here's our global CTO along with our global CEO. So this is a machine with a 4 meter and 8 meter and the power of 4 kilowatt with a stationary cutting table. And I would also like to add one more point out here, that this particular product again was given with the customized color. Usually our color, if you see, everything is blue. So, but this particular unit of customer wanted an yellow color specific request. So we have done that. And then this particular mechanism, you see, this is not a normal one. Whereas the machine is a gantry type, the work table is an exchange type. So this particular model is available with exchange table as well. So the exchange table along with fume exhaust is in the front side of the machine over here. And then the rear side, you have the table where you have the loading and unloading area. So this gives much advantage when you want to go for machine uptime. The reason why we choose this exchange table is you get ultimate productivity. The machine uptime is much higher than when you compare to a stationary working table. And this is again a normal stationary working table that is in Jamshedpur with 6 kilowatt. The machine size, you can see it is 5 meter by 13 meter. See, these are like odd sizes where you don't find a standard format machines available, where Messer is a pioneer in building such kind of machine, and we go up to customization of any length and width. As I said, length and width is not a constraint for this kind of laser systems. This is again one other system in Websco Belay. So these are like few things which we want to show you and bring some more advantages to customer when we see as a laser machine manufacturer. So I think I'm there, and then automation will be carried out by Mr. Ravichandran.
Right. Can you stop your screen sharing?
Sure.
Right. So thank you, Karthik, for that fantastic presentation on the advantages of laser cutting in manufacturing and its seamless integration with smart manufacturing technologies. Great to hear the kind of customized machines being offered by Mesa. So delegates, if you have any question for Mr. Karthik, please submit it in the Q&A box in your Zoom control panel. So our next speaker is Mr. Duraiswamy Ravichandran. He has a deep understanding of how smart technologies can unlock new possibilities in laser cutting. He's going to share his valuable insights on the role of automation in laser cutting and how it helps in increasing productivity and minimizing downtime. So welcome, Mr. Ravichandran.
Thank you. Thank you, Mr. Roy. Let me share my screen.
Right, sir.
And thanks everybody for the attending this session, so that this gives us an opportunity to dwell on what products we make and what products we offer to the industry and now and in future. So let me share my screen.
Yes, sir. Your screen is visible, sir.
Yeah.
Perfect.
Yeah. I'm good to go.
Yes, sir. Right, sir.
Yeah. So why we need automation? Now, automation has become it's like it's not a luxury, but a necessity in our daily life. In whatever field you take, that should be automation. That's the order of the day. And in cutting industry or the fabrication industry, why is it that we need automation? Because right now the machines which are being produced are highly productive machines. So if you don't have automation, then there will be a case where you will be underutilizing the machine. Machine will be waiting for material. It will be waiting for the one process after the other. It has to wait for the material to flow. So all those type of things. So when you have a highly productive machine, it's imperative that the process involved or associated with it should also be actually highly productive. So for that, you need automation and lean manufacturing. Like lean manufacturing is the trend is to reduce the manpower and to reduce the process also. So the minimum number of people and the minimum process you can do to affect a process or to manufacture is the order of the day. So you need automation. Then the not like earlier days where we make high, there is batch quantities were higher. Now the batch quantities have come down to a limited value because we don't want to create an inventory, or we don't want to unnecessarily load material, unwanted material onto the machine. So you will be processing what is needed for no, like, so it's like if you have a minimum order quantity, you process only for that quantity only. So there'll be a frequent shift in the loading type of materials, and you want to limit your idle time, and process has to be automized or digitized so that across the organization, people can view and analyze the process, and so that the lead time problems can also be solved. So all these things really needs automation. Automation is not just automating it, it is digitizing it so that you can analyze also. So majorly, if you need automation, the two areas where you want to automation are, it's on the material handling. How you take in the raw material, how you store it, how you shift it, and then how you feed it onto the machine. After you do the process, how you can actually affect the workflow from moving from one process center to the other process center, or else taking it, sorting it, packing it, all those things. So that's the material handling. And the second is process digitization. So optimizing the product, the process flow, monitoring in the real time so that what is being planned is executed or not, or is there is any lag in the actual execution. And if there is any lag, how do you use the data to analyze it, and so that in future you can avoid this occurrence of what you can say is non-adherence to the planned time. So this is two things. One is the material flow, and the second is the process automation. So on these two areas, we can make automation. First, let us talk about the material handling. We in Mesa, we actually work on plate cutting. So I want to showcase only on the raw material, which is it comes in terms of plate. Okay. So before that, I will go to this slide at the later stage. So if you have an overview of the fabrication, so you have a material inward, it is taken to a storage, unless otherwise you can, it's a small factory where it goes directly to the machine, but you will have a storage place, then it will be shifted to the manufacturing process. So it's something like storage yard. Then from the storage yard, plates are taken to the cutting area. If you see here, I just want to indicate this is the machine, plasma cutting machine, and these are plates waiting for to be cut, and then plates are loaded onto the machine. So it's like once the material comes, you have racks or pallets where the plates are kept, and then or skids on the side where plates are kept, and then again skids or racks where near the machine where there is a small segment of the raw material is kept, which can be fed to the machine. So this is the typical happening in all fabrication industry. But the unfortunately, even if it is more organized, what you can see is sometimes plates can be on the floor, or like plates of different thickness can be stacked one above the other, making it difficult for material retrieval, because it is not just storing, the retrieval also has to be as smooth as ever. So it's like you put a small plate on bottom, then put another two plates which are not needed now, and then you have to take the third plate from down. Then you end up shuffling all the plates, taking the plate from bottom. So that actually involves a lot of unwanted manpower usage. It's not a no value addition. It's like spending. So it's a waste of process time. So all these things should be avoided. So it's like the storage yard, if it is properly organized, and if the storage is done as per a plan, then all these things can be avoided. And on the cutting area, if you see, haphazard storage, or somebody would have bought the material, and before he could unload it to a pallet or something, like the machine or the forklift would have been called back for some other purpose. So it's like even on the shop floor, on the gang bay also you can find material. And the most thing is safety. So you can see on left, a big plate is being loaded onto the plasma machine. Maybe it's a 13-meter plate, 12-meter plate, or 8-meter plate by 2.5 or 3 meters. So if there's a small swing of the plate, then the safety of the operator is at stake. And for a small plate where you can have uh, manpower just loading it onto the machine. So even for a small plate, you need 3 to 4 people who will be lifting the plate. So excess manpower is being used. So these are all actually waste of manpower, and you are spending more on your process. Okay, so the challenges. So normally in a fabrication unit, challenges are if you don't have a proper storage. So whatever we talk about automation is not just onto the machine, it is also on the way how you store your material, how you retrieve it, and how you update it into your ERP system. Everything should happen seamlessly so that you have the inventory in real time. Suppose if it's not that way, so your process can be delay in your process. And if there is a delay in your process, then your productivity is reduced. And all the unwanted work which you are doing to retrieve material also adds on to your expense. So as the business improves, your material storage also, the method of storing material retrieving also should be more efficient. And if the challenges other than that is if you are not digitizing, you don't have proper tracking, real-time tracking is not possible, and your inventory, that's less visibility on inventory because maybe some plates, some raw material are hidden behind another raw material so that it doesn't come to your view at all. So you keep on purchasing extra material to top up and end up unused inventory. And then your space also is not well utilized. So it's like there's mismanagement, all these areas. So it's like material manpower management, and you will be depending on a lot of manpower, and there will be a lot of workflow disruptions because of inventory issues and retrieval of raw material issues. When you have all those things, your workflow is disrupted, and indirectly your expenses mount, and your what you can say your process tends to be inefficient. Okay, and your lead time also increases. So these are the challenges which can be overcome using automation in the sense your storage and retrieval system, your loading system, and your process automation or digitization. So material handling, it's like there are basic methods. Whatever I'm showing is one way of handling raw material. It's like it's not the way because, and it can never be one single way like how machines are sold, because each customer will have his own layout, his own way of handling the machine. So all the automation is nearly customized, literally customized to the customer's requirement. So I'll just let a video flow. This is one of the digital storage and handling system which we have actually manufactured in India and the district in Europe. So this is for handling a plate of 5 tons. So whatever you are seeing now is a plate of 6.5 meters by 2.5 meters with a thickness of 40 mm. That's a plate of 5 tons being handled and stored. So we have a vertical storage system. This is just an overview. This is not on with any machine. This is before the machine is being put on place. So it's like either you can load the raw material using a forklift or the crane, and the pallet is stored on this tower. So you can have 10 pallets, 15 pallets, depending upon the vertical space available in the shop floor. And then when this plate has to be loaded onto the machine, the pallet itself is pulled out, the required pallet is pulled out and moved to the other side of the tower system, from where the plate is being picked out and loaded onto the machine. And this is just a simulation. We have not put an actual machine in place. So we just have a platform just to represent the machine. So So imagine after this loads on the machine, the plate is loaded onto the machine and then it's cut. The comb fingers come and pick the plate and and unload it on another platform. So I'm showcasing this because this is a heavy load, like a 5 tons plate, and that also can be effortlessly handled, loaded onto the machine, and the parts cut in those plates can be unloaded. I would say effortlessly. So we have got sizes of 3 meters by 1.5 meters, 4 meters by 2 meters, and 6 meters by 2.5. And now we have added a size of 7 meters by 3 meters. So generally, it's like we load the plate directly onto the machine by a forklift or an overhead crane. And now using an intermediate storage system, it's like the effort is being reduced. Either you can have a tower where we can store all the material, or you can have an under-rover cart or a single cart, or just a station where you put a bundle of plates. And the vacuum loader picks up the plate and loads it onto the machine. After it's being cut, the comb unloader picks the cut parts and unloads it onto a single cart or unloading station. Or else, if you want to have a cost effectiveness, or if the cutting time is more, then we can combine the lifter and the unloader as a single unit, which can be a combi lifter. So what you saw in the video was a separate vacuum lifter and comb unloader. And then we have got premium version where you have separate, and a basic version where both the things like the vacuum loader and the unloader, comb unloader are combined into one unit. So you can have a full-fledged system with a tower and the loader and unloader working, or else it's like if you're looking at cost, then you can have a platform where the plates can be picked and loaded onto the machine, and from the machine the cut parts can be picked and unloaded onto another platform. And then a premium version where instead of having a combined combi loader and unloader, we can have a separate loader and unloader with the same type of platform, and you can have a like a cart moving in. So what you have a bundle over here, and where the plates are being picked and put and loaded onto the machine one by one, and in that time, a new bundle can put over here. So once this bundle is over, the new bundle is pushed in, and the empty card comes out. So it's like machine works 24 hours by 7. And this is for the loading side and this is for the unloading side. And on the premium version, the same type of effect can be used. This is like when you have a bigger plate and you have, and one thing is this can be coupled with additional machines. You have one machine, two machines, or three machines. A maximum you can go up to 4 machines. The loader and unloader can be used. Normal loader and unloader. Suppose if you are thinking of automating one single machine, then we have a solution called compact solution. So it's like it can be in line to the machine or perpendicular to the machine, where the plates are stacked on a platform, and the loader picks the plate and loads it onto the machine. And after being cut, the unloader, which is stationary and only has a vertical movement, comes down, picks the plate, cut parts, and then the new plate is fed inside. When the new plate is fed inside, the cut parts are put on this, what you can say, the platform. So we have two orientations, one in line to the machine and one is perpendicular to the machine. I have a small video to showcase that. So which is more self-explanatory.
Messer Cutting Systems India Private Limited presents the compact material handling solution for standard fiber laser machines. Compact automated material handling system ensures machines are fully utilized, contributing to a reduced cost per part and faster return on investment. Automation is an effective solution to reduce machine and manpower requirements. Messer Compact solution is reliable and stable to maximize productivity, reduces machine idle time between sheets, improves work environment and safety, improves workflow through the factory, eliminates manual loading and unloading, low maintenance. Compact solution comes in two variants: Compact I, material feeding system inline to machine shuttle; Compact T, material feeding system perpendicular or parallel to shuttle. Compact I and Compact T solutions have small floor print requiring minimum floor space. Sheet thickness checking for thinner sheets avoids multiple sheet loading. Symmetrical design of Compact T enables material feeding from either side of shuttle table. Messer Cutting Systems, creating solutions beyond machines.
And this is a small example where there are 4 machines with one tower system. And we have got 2 systems on either side of the bay. Just a representation on the CAD version. And then we have the smart crane also, where we have picking arms, and that can be like depending on the what you can say size of the machine and the weight of the plate being used. It can be single gantry or a double gantry with a single pick or a double pick, and it can be a combination of double and single also. So it's all highly customizable, and it's like the end of the picker can be magnet or it can be vacuum pads. And it's like the typical example is you have a machine, the plate is loaded over here. Once the cutting is done, the parts are picked up, sorted, and stored in pallets. Okay, so depending on the weight of the component and size of the component, the picker also varies. And process digitization, it's like the normal production flow is like raw material to planning, then to the machine where the actual process happens, and then the parts go to inventory. So this is like the normal thing with a work card and manual tracking, everything. But if this is automated, that's digitized, then the work is much more simpler, and the bottlenecks can be thought about, like can be identified much earlier, and the process can be more effective. So all these manual, if you are eliminating the manual intervention, so what we have is we have got 4 modules, and we call that OmniFab modules, wherein we have got the ERP Connect, which actually the interfaces with the ERP system of the customer and takes in the demand for the plates. We are talking only of plates. We are not talking of rounds or pipes or structural steel or castings. So it's only about plate and plate cutting. So it takes up the demand from the ERP system automatically, and then that is being split into uh, various thickness, type of material, and the nesting is done using OmniWin. And then the scheduler, if you have uh, more machines, then the scheduler automatically schedules the jobs according to each machine's characteristics, defined characteristics by the customer. And then the process happens in the machine. And once the cutting is done, the PDC, that's process data capture, it feeds in the information back to job scheduler, so that it takes in how many parts are being cut. And this is where the operator indicates if there is, say, he has cut, say, a particular plate, particular part of in a plate from a plate. Say the quantity cut is 20 numbers. but suppose three numbers are not accepted, are rejected, he can tick in reject quantity. Immediately, the rest of the quantity goes into the ERP system that stock has uploaded. So the job scheduler notes that three more parts are yet to be cut, and it gives information to the ERP system, and again that will be nested and scheduled and again cut. So all these things can happen automatically in the sense with minimum manpower intervention. And the fourth one, I had told that you have got four modules. So whatever I've explained has got three modules, and the fourth one is the machine insight, which gives live data of the machine utilization. So how whether the machine is cutting or not, basically first, and second, how it is cutting, what are the parameters with which it's being used, and then if there is an ideal time, there will be predefined classifications which will be picked by the operator, and that information is being shared. So if you have a error message, it will be automatically shown, and then you can always know because of a particular error how much time the machine was idle. So all those information is got in real time, and it's like it can be viewed on an app on any computer, linked computer. Okay, so the process, like the information on real time happening, is known by whoever is need to know. So it's like the ERP system. One is Machine Insight, and the other thing is ERP Connect and OmniFab job management, and then PDC, which is like giving back, updating the information from the machine to the system. Then the Machine Insight gives real-time information on utilization, error details, ideal time, and job overview. So it's like automating the process so that it will show bottlenecks in advance, and gives real-time feedback, which ensures high transparency and in total effective parts and order control. So it's like whatever I shown earlier. It's like the same type of manpower and the way it's being stored, that can be reduced to a minimum equipment being used and minimum manpower being used. So it's like when you use an automation or you have predefined places for storing and retrieving. So on a like a medium sector industry, if you can take, your saving will be somewhere around 8 lakhs. This is what we have calculated. It varies between user to user, but on an average. So if you have having a automation installed for really 1 crore or 1.5 crores, your saving will be direct saving will be somewhere around 8 to 10 lakhs per month per year. I'm saying, but it's not the case when you look into a bigger perspective. So when you have a storage and retrieval system, you're reducing the space of storage, and your inventory, you are planning the inventory well. So there will be a reduction in inventory, and there will be a reduced wastage also, and ultimately the productivity will increase by at least around 15 to 25%. I've taken an average of 20%. So even if doing a very conservative calculation, your saving or your return of investment will be maximum of 3 years with any automation being installed. So that will be the like, it's not a benchmark, it is just a indicative inference. Okay, so it's like if you have an automation, your maximum return on investment will be 3 to 5 years. So benefits of automation: you have increased productivity, lowered operating cost, and increased product quality. Then improved worker safety, because for you performing the unsafe work, the equipment will work. And since the equipment is going to do the repetitive or tedious jobs, your manpower can be used for more creative working, and this will definitely make us plan our workflow better, and that better use of floor space is ensured. And then with all this, decreased environmental footprint. Now coming to the end of the session, the current trends and innovation in the laser cutting industry are high power lasers. You'll be shocked to know that right now people are actually testing somewhere around 120 kilowatts and 150 kilowatts, so that you can cut more than 250 thick material. So it's like people are looking at using laser, which is more environmental friendly than the oxyfuel and plasma. So they are trying to right now plasma is nearly 60%, 60 to 70% of plasma market has been eaten up by laser, and right now efforts are being made to even utilize the oxyfuel capability. And it's like earlier it was only oxygen, nitrogen, and air which is being used as cut gases. Now, for much better technological by technological improvement, people are looking into nitrogen enriched air and mixed gas. Like you can, like what you can say is control the composition of nitrogen and oxygen in a given volume of gas, so that your gas utilization is reduced and your cutting quality increases. And then bevel cutting, which was not a big thing in laser earlier, has now come in existence. That is, people have started doing more of laser beveling, so that your the thing is the cutting surfaces are much better than plasma cutting, has less taper than what you get on a plasma cutting. So these are all the trends in laser cutting. And regarding automation, process digitization, and it's not single machine, end-to-end automation with material storage, retrieving, loading, and part sorting put into one. Nowadays, we are seeing increasing shop floors, which used to have at least 20 to 30 people working, reduced to 2 or 3 people with fully automated material movement, even using AGVs for shifting cut parts from one line to the other line. So such is the transition happening on automation. And with all these things, process analysis for future optimization. So the real-time feedback of the machines gives an opportunity to analyze the process and to optimize to reduce the bottlenecks. So these are the trends. So everything is done for increasing productivity, reducing wastage in terms of process time, in terms of manpower, in terms of material, and equipment usage also. So these are the latest trends in laser cutting and automation. And thanks everybody. I've come to the end of my presentation. And
Okay. So, thank you so much, Mr. Ravichandran, for that insightful presentation on the role of automation in laser cutting. Your deep dive into how automation can drastically increase productivity, quality, as well as profitability was incredibly informative. I'm sure that audience has gained valuable insights into how they can apply automation to improve their own operations. With that, let's open the floor to any questions from the audience. I'll just go to the Q&A box right now. So So there's a question from Mr. Yes. He's asking the explanation of laser cutting over plasma cutting was amazing. That's for Karthik. But I still have a question about in what case would you use plasma cutting over laser cutting? Karthik, can you unmute yourself?
Yeah. So the question is, how do you choose between a laser and a plasma cutting?
In what
So
case?
the,
At what case?
in what case? Yes. So it is like your end application. The first thing is that you want to consider the material thickness that you are trying to cut,
Right.
and what is that you're trying to achieve. That the profile is having any intricacies? Is that achievable by the process itself? Because not every process is capable for every particular end application. So you first need to check whether your particular job suits the plasma configuration or the laser configuration based on the thickness and the type of intricacies that you're getting into. So basically the thickness will give you the major clarification. So if you want to cut 120 mm or 130 mm, you can straight away step into the oxyfuel. If you're having somewhere thickness around 30-35, you are flowing in a range between 30 to 50 mm, then you can obviously go choose for plasma. If your thickness majorly depends upon 20 or 25 mm, 16 mm, 12 mm, 8 mm, 6 mm for that matter, then you can still stick to laser. If your definite choice of the cutting is only up to 8 mm or 10 mm, I would say please go for laser, because that has much advantages over your cutting, your precision, your productivity. So in these three aspects, if you want to consider, and if your thickness is less than 10 mm, obviously you can choose laser. And that's how you go split for it. And even within laser, the selection of power depends upon, again, your cutting thickness. So take a decision with thickness, with the process that you are going to do, with your end application, and then you can select your method on which way that you're going to cut.
Okay, thanks, Karthik. Does even Meso helps a customer to select a particular type of laser cutting machine?
Definitely, sir, definitely, because every customer and application is completely different, because some customers have their own product, some customers serve the industry, they do job work for the main or tier one companies of OEMs. So in that cases, if any customer solution that we recommend is based on a complete technical discussion. So through the discussion, we make the product clear, we make the process clear, we try to understand what the customer is actually looking out for, and then we suggest our products with the process, and then we go for finalizing.
Thanks, Karthik, for the clarification. I think, yes, you got your answer. Thanks for that question again.
I would like to add one more point also, Mr. Roy. It is that we also support in terms of, even if customer is having some drawings of theirs, which they want to try, checking out, okay, this is how I get a feel, that this is how I get a quality output when I cut in a plasma and when I cut in a laser. So both the process that we can give some demonstration samples from our production plant, that what I've shown in the slide, which will make them feel, okay, this is the exact quality that I look for, that which also they can select. If they are meandering between two systems, which I want to choose exactly. So that support is also being provided from Messer.
Oh, that's great. So there's a question from Mr. Akash Bansod. He's asking that which laser source and laser head used in Mesa cutting machine? Mesa has its own source or head, or source from any other company. So if you can just Ravichandran sir, or right.
We predominantly use IPG laser and Precitech cutting head, but now with the improvement in Rakers and Max Photonics, we also offer customers with Rakers and Max Photonics laser, and also cutting head. Also, we have got a choice of Ray Tools cutting head.
Thank you, sir. I think Akash, you got the answer to your question. Mr. Sandeep is asking what will be the ROI time for metal handling equipment. I think that was already there in the presentation of Mr. Ravichandran. It is he is saying that it's going to be 3 years, but again he mentioned that it can be case to case basis and 3 to 5 years of ROI. Am I right, sir?
Yes, definitely.
Right.
It's like any automation is customized. It's not like a general machine. So it's like whatever we showcase are modules, so which can be further customized also based on the customer requirement, and it depends on the layout, it depends on the machine capabilities what they have, and their way of working and their process intricacies.
Thank you, sir. Mr. Umang Gupta is asking, I want to know about laser pipe cutting machines, its speed in comparison to saw or blade cutting machines. We are more discussing about the blade cutting.
Regarding cutting speed, if you are looking in the surface speed, both are same. But Mesa, we are just started unveiling our pipe cutting machines. We do have plasma pipe cutting machines, but right now only we are actually launching our laser pipe cutting machines. So it's as much early for us to give you a real feedback on that.
Someone asking, aluminum cutting, can I run continuously? Mr. Ashok Nath is asking.
Aluminum, what's it, sir?
Cutting, can I run continuously? I think.
Yeah, you can run. One of client is running it 24/7.
Okay. Okay, Mr. Anjan is asking Karthik how to find the best machine to purchase. I think he was more apt in that. Karthik was, though it cannot be one.
Hi, Mesa.
No, it is like it depends upon the requirements, and even if our own product portfolio, if you see, we have from a very basic components to a very premium machine, which have the multiple tools configuration, not just one single station. So it is again, I would say, go for understanding your application with some capacity of your resource, because I would say every machine is a capital investment for any customer. So when you consider capital investment, it is wise to take some additional capacity based on your particular product or your particular business nature, so that it helps you to not just invest for today, but it also takes care of your at least near future, maybe next 2-3 years or at least 5 years, because at least then you get your ROI, but not just today's requirement, but also for your 2-3 years requirement.
Thanks, Karthik. Mr. Akash is having one more question. How Mesa is better than fiber laser cutting machines, which are cheap and easily available in market, especially imported from neighboring country?
It's basically the type of building the machine. It's like how you build the machine. There is no compromise. The design is German. All our machines, Messer is a German company, and we ensure that the best manufacturing practices are always kept in producing the machine. And the elements which are used in the machine are of top quality. It's and from the reputed manufacturing. It's like there is no compromise on the quality of parts used in the machine. So it's like right from the welding, right from aging of the structure, right from relieving the stress on a welded structure, to the way its machining is done and the surface treatment is being done. Everything follows a process. It's not just there is no cost reduction in that. It's like delivery of quality only. So that's the main aspect we would like to insist on. And then the deliverable in terms of process. What is how that has to reach the customer. That's how we look at it.
Thank you, Ravichandran sir and Karthik, for not taking up those questions.
Yeah, to add one more point to Ravi sir's the delivery of quality, I would recommend, I would also request customers who are interested to see how the way we build machines, they can directly experience it, and people are welcome to our factory to see the machine building process. How do we make it over here with all the quality practices in place?
Right, that's a good assurance. So we are already running out of time, 10 minutes past. So thank you, Ravichandran sir and Karthik once again. So in conclusion, we can say laser cutting is not just a tool, it's a transformative technology in the era of smart manufacturing. By leveraging the precision, flexibility, and automation capabilities of laser cutting, manufacturers can stay competitive and meet the demands of modern production environments. As this session draws to a close, I want to extend my heartfelt thanks to each one of you for joining us today. We hope you have enjoyed this episode of Bojapur Industry Presents Digital Dialogue on Laser Cutting in Smart Manufacturing, sponsored by Messer Cutting Systems India. So thank you once again, Mr. Duraiswamy Ramachandran and Mr. Karthik M for your time and participation. With that, we conclude today's session. Thank you for participating, and we hope to see you again next time. Till then, take care and stay safe. Thank you, Ravi sir. Thank you, Karthik.
Thank you. Thanks, everybody.
Thank you, Subhajit sir.
Bye.
Thank you. Bye. See you.